Hi there, welcome to this video where we're going to solve some trigonometric equations that are involving inverse trig. So again, you need to know your unit circle values and not only sine and cosine of certain angle values, but also how to work this in reverse, where if I have a certain sine value of an angle that equals, say, 1/2, what angle is that going to return? So we'll use sine and cosine values from the unit circle. We'll solve linear equations and then rewrite a trig function in terms of its inverse. So let's start. For an inverse trig function, the inputs are trigonometric ratio values and the outputs are angles. We're reversing, right? Normally we plug an angle into a trig function, we get an output. We're kind of reversing this. For example, sine inverse of 1/2, that's going to be pi 6 because sine of pi 6 is equal to 1/2. But now 1/2 is the input and output is pi 6. Therefore, when solving an equation that involves an inverse trig function, the solution will be a trigonometric ratio value. For example, given an equation is sine inverse of x equals pi 6, the solution will be 1/2. Recall, the angles and outputs for inverse trig functions are restricted to 2 quadrants because the functions must be continuous. I need a positive output and a negative output. This means that these types of equations should expect to see outputs that are negative angle measures for arc sine and arc tangent, okay? And I have an image of this that I really like for our trig functions. Arc sine, also known as sine inverse, is going to be in quadrants 1 and in quadrants 2. So this is what we will call arc sine or sine inverse. It's just another way to I don't know. It's the same way, you know, sine inverse is the same thing as arc sine. That's what I'm trying to say. I don't know why I'm fumbling that. And then we have arc cosine is going to use quadrants 1 and quadrant 2. Y equals cosine inverse. And then for tan, arc tan is the same as arc sine, except they do not use the quadrantal values. So y equals tan inverse. Okay, and so these are really easy. You know, your positive values are going to come from your positive quadrant 1 angles, and your negative ones will come from quadrant 4 here. This is quadrant 4, or technically quadrant -1, because they're negative angles. The only ones where you have negative values, you're going to have to use angles from quadrant 2, because that's where your cosine values are negative. Okay, so let's go ahead, let's jump into some examples. Example 1. The function z is given by z of x equals 12 arc cosine of x. Solve z of x equals 8 pi for values of x in the domain of z. So right away I'm just going to copy down my function. We have 12 arc cosine, which is cosine inverse of x, and we're equaling this to 8 pi. So what we want to go ahead and do is I want to isolate my cosine of x. So I'm going to divide both sides by 12, and we get cosine inverse of x is equal to, this looks to be, what is that, 2/3? 2 pi thirds. Okay, and then I'm going to go ahead now, and I'm going to solve this. I'm going to take a cosine of each side, and so we get x equals cosine of 2 pi over 3, which means that x is equal to -1/2. Okay, there you go. That's it. Pretty easy, right? Let's look at another one. The function p is given by p of x equals sine inverse of 5x. Solve p of x equals -pi thirds for values of x in the domain of p. So again, I'm going to take p of x, which is arc sine or sine inverse, and it's actually 5x, and we set it equal to -pi thirds. So it's really kind of easy. We're solving for x. How do I undo a sine inverse? Well, I'm going to use my normal trig function. I'll take sine of each side, sine of this side, and what we get is 5x is equal to sine of -pi thirds, which is the same thing. Kind of, if you ever get confused about negative angles, just draw it. It's the same angle as this, right? Which is 5 pi thirds. So if you ever want to switch it over to the positive angle, you can, right? And so our y value there is going to be root 3 over 2. So 5x equals square root of 3 over 2, and it's negative because it's in the negative quadrant. Okay, and then I'm going to go ahead and I'm going to solve now by dividing by 5. Divide by 5. And so our solution, x is equal to negative square root of 3. This 5 is going to multiply with this 2 to give me a 10. And there you have it. Okay, so nothing too crazy with the inverse. I'm just using a trig function to kind of undo that. Okay, here's a couple of practice problems. Please pause me and then I'll talk through this one. Okay. Practice problem number 1, I want to isolate 2x, so I have to undo this multiplication of 12, so divide both sides by 12, and then I want to undo this arc sine or inverse sine, and so I take sine of each side to go ahead and kind of cancel these out, and we get 2x is equal to sine of pi fourths. That reduces, and sine of pi fourths, the y value is square root of 2 over 2, so then we divide by 2, and we get our answer, which is square root of 2 over 4. Pretty easy and straightforward. Nothing too crazy yet, okay? Here's another practice problem. Please pause me, try this one, and we'll talk through the solution. Okay, again, this one pretty straightforward. Cosine inverse of 4x. I'm going to undo that cosine inverse by taking cosine of each side. There's nothing to undo on the outside, so I have cosine of pi 6. This value is the square root of 3 over 2. And then we divide by 4 on both sides. And that's how we get our final answer here. X equals square root of 3 divided by 8. Pretty straightforward. Okay, last couple of examples. This is where maybe we get a little bit more complicated. But in this example, we have the function q is given by q of x equals 3 tan inverse of x over 2. Solve where q of x is equal to pi for values of x in the domain of q. So again, I'm going to take my function and we will set them equal to what they want, x over 2, and this is equal to pi. So we'll divide both sides by 3. Tan inverse of x over 2 is equal to pi thirds. And then I'm going to get rid of the tan inverse by taking a tangent of each side. And I get x over 2 is equal to tangent of pi thirds. Pi thirds is the big angle, so it gets the big value. This should be square root of 3. Okay, and again, if you don't know tangent that way, just you can do sine of pi thirds divided by cosine of pi thirds, right? Which your x value is 1/2. You get root 3 over 2, which is 1/2. You see how much this kind of like takes a lot longer. Okay. Oh wait, I flipped these. See, this is why I don't even do it. I messed it up. It's y over x. This is root 3, 1/2. Right, and you get square root of 3. I just know bigger angle has the bigger square root of 3, right? The smaller angle, the pi 6, is the smaller one. You divide it by 3. Okay, anyway, so we get this, and then lastly, divide both sides by 2, and we get x equals to square root of 3. Ta-da! There you go. Not too shabby. Okay. Practice problem, kind of same idea. Go ahead, please pause me, try this example, and we'll talk through the solutions. Okay, here we have arc tan of 3x is equal to negative pi fourths. You're going to go ahead and take tangent of each side, and so you have to evaluate tangent of negative pi fourths. Again, you can do sine over cosine, but you're going to get negative 1 when you go ahead and evaluate here. And then you just divide both sides by 3. Okay, this problem is even easier if you don't even have to evaluate this, if you just know the y value of, of this graph here. Okay, so anyway, there you go. X equals negative 1/3. Okay, I think this is the last example. Last example I got for you. Here they have the function w is given by w of x equals 3 sine inverse of 2 pi x. Find all values in the domain of w that yield an output value of cosine inverse of -1. Hey, we're going to have to do some calculation values here. So what we get is 3 sine inverse of 2 pi x equal to cosine inverse of -1. The first thing I'm going to do here is I'm going to evaluate this value, okay? So essentially what this is saying, right? What this is saying is cosine of what angle equals -1. And hopefully you recognize that as pi. That is pi. So I just evaluated that. I kind of flipped this, right? So if you're ever confused, just rewrite it in a normal value or a normal equation where you're trying to solve for the angle, okay? And then we bring down our left-hand side. So 3 sine inverse of 2 pi x. And now I'm just going to go ahead and divide by 3. So I get arc sine of 2 pi x is equal to pi thirds. And I solve this way, just by taking sine of each side. Sine of each side. These cancel. Whoop. Had a glitch. Those cancel. And so we get 2 pi x is equal to sine of pi third, which gives us 2 pi x is equal to, what's that, square root of 3 over 2. There's our y value. Okay, and then I'm going to divide by 2 pi. Divide by 2 pi, divide by 2 pi. Okay. And so final answer, x equals square root of 3 divided by, these multiply, and you get 4 pi. 4 pi. Okay? There you go. Not too bad. The biggest kind of hiccup on this hurdle was evaluating cosine inverse of -1. Not too bad. All right, here is a practice problem. Please pause me, try this one, and then we'll go ahead and talk through the answer. Okay, hopefully you got x equals 1 over 2 pi. How do you get that? First thing, you have to set the two functions equal to each other, and you have to evaluate your right-hand side first. Tan inverse of square root of 3 is pi thirds, right? Your pi thirds angle is what gives you square root of 3. Again, kind of have to solve this equation over here. So I think knowing your equation of tangent function is very important, so you can have these values ready. Then we just go ahead and take cosine, right, of each side. Okay, these cancel. And we get pi x is equal to cosine of pi thirds. Well, that value is 1/2. So you just evaluate that, and then we're going to divide by pi. Divide by pi on each side. So you get 1 over 2 pi. All right, hopefully in this video you learned how to solve some equations that involve inverse trig expressions. And yeah, I mean, no big deal. Take a sine or a cosine value to the other side. The hardest ones are when you have to evaluate an inverse trig expression, right, to find the angle. But it's just what we've been doing in reverse. Give this video a thumbs up if you learned something. I'll catch you in the next video. See you later.